into your Excel analysis. So depending on what version of your Excel or what version of Excel you're using, you have to do things differently. In this one, which is 2010, I go to File and I click on Options. In 2007 or earlier, you have to click on this symbol of Microsoft, which is usually on the top left, and then you go to the options. Then you click on Add-ins function, and you highlight the Analysis Toolpack. And then you go. And in Analysis Toolpack, you add in your, it's usually not checked off, so you add in your Analysis Toolpack, you OK it. And this data analysis now should show up. When you click on Data, this data analysis now is in the very right corner. So if I highlight all of these guys, including the first row, and I click on Data Analysis, for some funny reason, Excel always brings it to two-factor ANOVA. You need to drag this bar and take it to the top and get a single-factor analysis. So it's asking me to do again for your input. So again, while it's highlighting, I'm going to highlight all of these again and bring it back down again. Since I highlighted the first row, my first row is not data. They're all text. So I have to click on this thing, on this box that says labels in first row. Now it reads my label if I do that. If I don't do that, it takes the label and my data would be just completely different than what it's supposed to be. If you don't do it, and if you highlight from just the numbers, it just puts column A, B, and C. Arbitrarily, just gives an A, B, C number. So it's always best to give a label to each column and then click on this thing and include it when you are setting up your input range here in this row. Then it's asking you where do you want to, oh, by the way, alpha is your significance level. Somebody asked, can I put a different alpha, or does it have to be always 5%? Here is where you can change this 5% to 1%, or to whatever the problem gives you, or whatever you think you like to have it, 2.5%, whatever. 5% is for this problem, so we want to keep it at 5% to see if our numbers came out to be the same. Then it's telling you where do you want to have your output of this analysis. Do you want it in a new worksheet? I do not recommend that, because it's going to put on there sheet 2 or sheet 3, or may even give you a new sheet. Do you want it in a new workbook, so that means it takes you completely to a different workbook? Or I just want to see it right here. Since I want to see it right here, then it's asking you, okay, which cell do you want me to start giving you the data? Let's say I like it here. So I'm going to click on this thing, and let's say I want it to start from here. So that is on G15. And pretty much you're done. So by just highlighting this thing and setting up your Excel for data analysis, the result that ordinarily manually with hand takes you 20 minutes or half an hour is going to come out in a matter of a couple of minutes. So I usually expand these to read everything. Notice Tiger A, B, and C, they're all 5 each. This is their average. I mean, this is the total, this is their average, and even tells you what their variance is, which is a square of a standard deviation. It tells you that your numerator is 70, that's what we exactly found, between the groups or SST. It tells you within the groups, the sum of the squares of the error is 12, Degrees of freedom of numerator is 2, degrees of freedom of denominator is 12. It divides 70 by 2 is 35, divides 122 by 12 is 10.1666. My F critical is 3.44. And notice, I'm sorry, my F calculated is 3.44, and my F critical, the one that we read from the chart, is approximately 3.89. So it gives you all these values. Now, interpretation of the result is on you. You know that if this number is less than this number, you will not reject your null hypothesis. So setting up the null hypothesis is something you need to do, step 1. Step 2, you should be aware of these two numbers. Step 3 is pretty much what Excel does for you. And then you make your conclusion and your step 4 comparison of results. Any questions on this? So anyway, Excel is a good way of checking your analysis of variance in no time. Any questions once, twice before I turn it off?